Okay, so if we took out, normally I get you to do this, but because everything is time crunched, we're just kind of, I'm going to tell you what this is, okay? This is a true statement. This is a true statement. This is true. This is false, and this is false. So, can you see a pattern that allows you to add and subtract radicals? If these three are true, and these two are false.
They have the same, like, I don't know what the number's called, but the little number.
The little number that floats here? Mm-hmm. The index number, that's correct, that's one of them. The index number has to be the same, okay? And then you can add and subtract them. What else?
Numbers inside, they called the Radicands.
That is right. Yes, so if the Radicands are the same, and the index numbers, you can add and subtract them. Here, it's not true because even though the index numbers are the same, the Radicands are different. And here, the index numbers are different, so you cannot combine them. Okay? So to add and subtract radicals, the index number must be the same, and the
Good morning, Royal Bay. I hope you're having a wonderful Wednesday. It's me, Rory, for your morning announcements. The school store is open today. The following students have spiritware items that are ready for pickup.
that the radicand and the index number must be the same. We can combine them. So this one, the first thing you do is when you get a question, look at the index numbers. Are the index numbers all the same in this question? Yeah, it's all twos. Are the radicands the same? Yes, they're all sevens. You can combine them and treat the radicand or the radical like it's a variable. So you know when you're adding like 2x plus 3x, what does that equal? 5x. You only add the numbers and the x's just stay as an x, right? That's the same idea for this. So if I have 8 root 7s and I take away 3 root 7s, how many root 7s do I have? You have 5 root 7s, right? And then, now I'm just showing every step. You don't have to show every step. And then I take those 5 root 7s and I add it to 15 root 7s. How many root 7s do I have? That is your final answer. Okay? So second question, 2. Are the radicands the same? Are the index numbers the same? So what's the answer? $18 and 12 is 30. 30 minus 7 is 23. So it's 23 root 5 of 10. Thank you. Even if it's a variable, x in this case. 5 root x minus 4 root x. How many root x's do I have? 1. So you can write 1 root x, or the convention would just be to write just root x. You don't have to put the 1 in. Okay? So it's just like combining like terms like we did in algebra in grade 9 and 10. I think that's when you learn that. All right, question number 1, and that'll bring us up to break. So we've been adding and subtracting radicals when we have the same index number and the same radicand. So what if the index number is the same, but the radicands are different? What do we do? Anybody? Anybody have any ideas how I can add root 2 plus root 8? rewrite it. Make root 8 an entire radical. So what multiplies to 8? 4 and 2. See, I'm just going to do the Factor tree here because I think most people seem to do the Factor tree. If you know the perfect squares, that's fine. Do the perfect squares. So I'm looking for groups of 2, so I can pull a 2 out. So I end up with 2 root 2. So root 8 is the same as 2 root 2. That's the stuff we did in the last unit. Now we're going to take that fact, and that allows us to add it to the other root 2 to give us our final answer of 3 root 2. Okay? So this is what you do. When you get a question where the radicands are different, but the index numbers are the same, you reduce the radicand to its lowest form. Okay? So you make it an entire radical. You break down what's inside. So the 12, do 4 and 3, 2 and 2. So I can pull out a pair of 2s. The 5 is still there. Times the 2 you pull out, and there's a root 3. And if you can do this in your head, that's totally fine. I'm just going to show every step. The 48, I can go 6 times 8 is 48. That's a 3 and a 2, 4 and a 2, and a 2 and a 2. I'm looking for groups of 2. So I can pull out 2 sets of 2s, right? Which gives me the 6 is still there. I pull out 2 different 2s. What's left inside is a root 3. And then it's 5 times 2. So I have 10 root 3 plus 6 times 2 is 12 times 2 is 24 plus 24 root 3. Add them together to get 34 root 3. Is that okay? Yes? So then, if you don't get a 3 in both, then you can't add them together. You would just rewrite, like if this was a 4 or say a 5, you would just write 10 root 3 plus 24 root 5. And you can't add them together. But your first step is to make them reduce the radicand down to its lowest form, okay? And these are all rigged questions, so there should be ones that add together. So let's do, well, let's do this one. Next page, we'll do C here. Okay. They have the same index number, which is 2. That's good. But the radicands are all different. Okay? So we're going to break them down. So what multiplies to 27? 3. So that becomes a 3 and a 9, which is a 3 and a 3. I'm looking for groups of 2. So I can pull out 1, 3. So I get 7 times 3 with a root 3 left inside. 75 is 25 and 3. 5 and 5. So pull out these 5s with a root 3 left inside. So it's looking good already. And then I'll do the last one, purple. 147 is 49 and 3, which is 7 and 7. Then multiply the numbers in front. So I'll get 21 root 3 minus 15 root 3 plus 14 root 3. And then combine them. 21 minus 15 plus 14. Sorry? 20? Yeah, it is 20 root 3s. Okay? Is that okay? The only other little hiccup that you could get would be if it's a cube root, but then when you do your factor tree, you're just looking for groups of 3, right? It's the exact same process. All right. I would like you to do question number 2, please. But what I would do is I would pull them off to the side and simplify each one separately. So for example, let's do the root 108 over here. What multiplies to 108? Anybody know? 9 and 12. Impressive. That's 3 and 3, 4 and 3, 2 and 2. So what am I pulling out of that one? The 2's and one of the 3's. And 2 times 3 is 6. So root 108 is the same as 6 root, not double root, 6 root 3. Okay? Just leave them there for now. We'll deal with the root 8. Do it in a different color. 4 and 2, 2 and 2. So I can pull out a 2, and I get 2 root 2. Everybody okay so far? These are, if you break them down separately, it's okay. 48 will be purple. 6 and 8, 2 and 3, 1, 2, 2 and 2. So what am I pulling out of that one? 2 sets of 2. So I get 4 root 3. Is that good? And the last one is the root 50. 25 and 2 is 5 and 5, so I'm going to get 5 root 2. Okay? We're all good? All right, so now we just put them back into our original equation. So the root 108, this negative 5 drops down, so we'll have negative 5. Root 108 we said was 6 root 3. So I just go, well, that's times 6 root 3. Plus, the 3/4 comes down. Root 8 we said was 2 root 2. The next term is the negative 5 over 4 comes down. Root 48 we said was 4 root 3. And the last one, the 1/2, and root 50 we said was 5 root 2. Okay. All right, what should we do now? This is our question. What should I do? Combine them. Let's clean this up first, right? We got this 5 times 6, this 3/4 times 2, da 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 da. So let's clean this up. So what's 5? Negative 5 times 6 is negative 30 root 3. What's 3/4 times 2? Sorry? I can't hear you. 1.5. So I'm going to write it as a fraction. Thank you. So 2 times 3 is 6. 6 over 4. So this would become 6 over 4, which reduces to 3 over 2. If you write it as a decimal, that's fine. I won't take marks off, but if you're planning on taking Math 12 or calculus, you should be comfortable with fractions. Okay? So 3 halves root 2. What about this next term here? Negative 5 over 4 times 4. What can you do right away with the 4s? They will just cancel out because that's like 4 over 1. So you could go 5 times 4 is, 5 times 4 is 20. 20 divided by 4 is 5. Right? The quick way is just cancel out the 4s. So it's minus 5 root 3. And the last one, what's 5 times a half? 5 over 2 plus 5 over 2 root 2. Okay. So now we've simplified all the terms in front. Now we can start adding and subtracting. So what are my like terms here? I.e., what have the same radicands? The 2's and the 3's, right? So we got the root 3's here. What's negative 30 minus 5? Negative 35. So I get negative 35 root 3. And then the other ones are those. 3 over 2 root 2 plus 5 over 2 root 2. If you're adding fractions, you need a common denominator. Do we have a common denominator? We do, so we just add the numerators. 3 plus 5 is? So I get 8 over 2 root 2. What's 8 over 2? And that is your answer. Okay? So, obviously these questions take more time. There's more places to go wrong, just because it's a bigger question. But if you break them down step by step, like we did over here, and then plug them back in, simplify all the terms in front, and then you can add them together. Okay? Are there any questions about that? It's the same stuff we've been doing, with just adding another layer to it. I would like you to do 5A, please. That's the only question I need you to do. Okay. So here we go. This is true. This is true. This is false. This is true, and this is false. Oh my gosh. Frozen. There you go. True, true, false, true, false. What is the rule for multiplying radicals? Some numbers. Index number has to be the same. Does anything else have to be the same? Radicand? Well, I multiplied root 2 and root 3 and got this. So those are different radicands. So the only thing that has to be the same when you're multiplying is the index number. Okay? That's it. If you have the same index number, you can multiply together. Okay? So you just can't multiply a cube root and a square root. You can't do that. But you can multiply cube roots even if they have different index or radicands. Okay? All right. So we'll scroll to the bottom of the page here. Root 8 times root 8. And when you multiply them together, it's the same radicand, or sorry, the same index number. The index number doesn't change. So this is going to be a square root. And just multiply the inside. What's 8 times 8? 64. And then always simplify. What's the square root of 64? 8, which you could have figured out from the beginning anyway. If you multiply two square roots together, the square root sign floats off into space. Okay. What doesn't float off into space? Next one, 4 root 5 times 3 root 6. Same index number. Multiply the numbers in front. 4 times 3 is 12, so 12 hangs out there. You're going to have some sort of square root. What is going to go inside of that square root? 30, 6 times 5. Right, so you just multiply those two. All right, C. Even if it's variables, you can still do it. 4 times 3 is 12. Root x times root y is xy. Square root of xy. All right, and D. What's my answer for D? Heard somebody say it. Negative 10 root 9 6. But you always have to simplify. So you got to simplify the 96. Okay? So if you break up the 96, you'll get 8, 12, 4 and 2, 2 and 2, 4 and 3, 2 and 2. Okay, so you're pulling out two groups of 2, right? So you get negative 40 root what? Nope. There's the 2 and the 3, so it's root 6. Okay, so I want to show you two things here, two little tricks. So I feel like everybody's pretty comfortable at factor trees. And I've told you to always go to the bottom, okay? There's a shortcut. If you're looking for groups of 2, I got 2 4s up here, right? You just pull a 4 out. As soon as you get any group of 2, you can just pull it out. Okay, so it saves you having to go all the way down to the 2s. All right? If you want to go all the way to the end, do that. You'll get it right every single time. But it's just a little trick. I could have stopped there, pulled the 4 out, times it by 10, get negative 40, and I'm left with a 2 and a 3. Okay? The other thing with these types of questions, though, before you multiply, if you can, simplify these things up here before you even multiply. So if I had gone, and you'll see this especially when we get into bigger types of questions with bigger numbers, the 8 I could write as a 4 and a 2, 2 and 2. So I can rewrite that as negative 2 times those 2's with a root 2 on the inside times, that's going to be a 4 and a 3, it's 2 and 2. So I'm going to get 2 times 10 root 3. Okay, and then multiply them. Negative 2 times 2 is negative 4 times 10 is negative 40. Root 2 times root 3 is root 6. Okay, so we got the same answer. If you simplify first, it usually saves you on the back end. Now, for this type of question, it's about the same amount of work, whether you simplify first or after. But you're going to see in the next question, it's easier if you simplify first. Because as the numbers get bigger, you're multiplying big numbers together, you're going to get massive numbers. B, 30 would just be like a 10 and a 3, which is 5 and 2. There's no groups of 2. So, but you always look to simplify. Okay? I just knew that one didn't simplify. Okay, let's do one more and end the day. And let's do next page. We'll do B. All right. So, we'll do A first because A kind of leads into B, just as a good, and we don't have to simplify it, this one. All right. If you have a number, so these types of questions are like this. 2 times x plus, I don't know, 4. Remember these from Math 10? You have a number outside of brackets. What do you do with that number outside of the brackets? Right. You multiply it in, right? You go boom, boom. I've heard people call it rainbowing, call it foiling. You just say multiply it by everything on the inside. So this would give you 2x plus 8. You guys remember that from grade 10? Okay. It's the same with this. We have a number on the outside with a bunch of stuff on the inside. So you multiply it in, all right? So this root 5 goes to that one and that one. And there's a 1 in front, right? If there's no number written, we know it's a 1. So I could go 1 times 2 is 2. What's root 5 times root 10? 50. So I get 2 root 50 minus what? Root 25. What do you always need to do? Simplify. So the 50 will break up into 25 and 2, which is 5 and 5. Pull the 5s out, multiply by the 2, and you get 10 root 2. What's square root of 25? Can I combine anything else? Right? This one has a square root, this one does not. So this is it. You just stop there. Okay. So next one is the exact same, except we have 3 terms on the inside and bigger numbers. Okay? So you could just go carpet bomb the root 5 all the way through, all right? Or we can simplify these things on the inside, which I suggest, okay? Because it'll make your life easier. You're dealing with smaller numbers. So, root 45, what is that? What multiplies 45? 9 and 5, which is a 5 and a 5. So I'm going to rewrite the whole question down here. 45, I can pull out a 5 times 3. I get 15 root 5 minus 8 root 5. It doesn't. I was just testing. See? Making sure you're paying attention. No, I didn't. 3s? Is that right? I'm glad that everybody got a little angry there. Means you're actually paying attention. So 3 times 3 is 9 root 5. Is that better? Thank you. That's all in the recording too, so you can watch it and watch me get the question wrong. What about the root 20? Can I simplify that? No. 5 and 4, 2 and 2. 6 root 5. Why did this work out well? Because what? They're all 5, so we can combine them together first, right? Nine minus 8 is 1, plus 6 is 7. So that made our life way easier. This is much simpler than this thing. Okay? So 2 times 7 is? Root 5 times root 5 is? You can write root 25, but what's the square root of 25? 14 times 5 is 70. All right? Now you could have done it by multiplying this into all these, but you're going to get 5 45s, which is, I don't even know what that is, 450 minus 45, 405. That's a big number, right? You have to break down the 405, okay? And 5 times 20, that's 100, but whatever. You're going to get bigger numbers, okay? So it's usually easier if you simplify everything first. In this case, we're all root 5, so it's simplified to one expression. Multiply it out, you can't simplify that answer anymore. You're done. Okay, so it might be a bit more work at the beginning, but it saves you a ton of work at the end. Okay? Any questions? All right, we're going to do question number uno and number 1 and number 7. But in 7, I want you to do A2. Oh, you can do all 7. Yeah, all 7. Sorry. And that'll take us up to the end of today.